Okay, now we shall be starting with our new chapter, theoretical distribution. Okay, so this is actually a very simple chapter, and with good practice, you'll be able to master this chapter. Okay, on the face of it, it looks complicated, but trust me, it was actually a very simple chapter. So this is actually divided into three sub chapters. The first is binomial distribution. Okay, the second is Poisson distribution, and the third is normal distribution. Okay, so first I shall be starting with binomial distribution. So just take a note of these subsections within this chapter: binomial, Poisson distribution. Okay, and then the last one is normal distribution. Okay, so I'll be starting with the first section, which is binomial distribution. I will first explain to you, okay, what is the need for a binomial distribution. Okay, so for example, let us take the case of a toss of a coin. Okay, if I take a toss of a coin, for example, what happens is I toss a coin and either I get a head or I get a tail. These are the two possibilities. So it is quite simple for me. In the chapter probability, I saw how we have to see the number of outcomes in the case of a toss of a coin, say once, twice or thrice, etc. So we worked out the various possibilities manually by hand and we found the required probability in the question. Okay, there was no issue. So why do we need binomial distribution? Now binomial distribution, to come to binomial distribution, I'll first go back to my toss of a coin example. Suppose I give you a problem where I say that a coin, okay, I tell you that a coin is tossed, say 6 times. Okay, a coin is tossed, not 6, I'll say 10 times. A coin is tossed 10 times. What is the probability of getting 7 heads? If I give you a question like this, will you be able to do it with a manual method? Is it possible even? It's too cumbersome and it's too complicated and you have a lot of possibility for getting into error. So it is not advisable to go for the manual method in case of this kind of numbers. Okay, so there we need to apply binomial distribution. In those cases, it is very useful. So first you write down, where is binomial distribution used or applied? Where is binomial distribution used? The first case where the first condition is, see, there are some conditions for using binomial distribution. So the first condition is that where the number of trials is too large but finite. Finite means it is a definite number. We know that number, okay? It is not infinity. So the number of trials is too large. Like it cannot be once, twice or thrice, because once means, yeah, I can do one head or tail. Twice means it is head, 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 tail, tail, head and tail, tail. Thrice means same way. So it is to be a number which is too large, but at the same time it is a known number. It is to be finite. So this is the first condition for using binomial distribution. The second condition is, see, when I toss a coin once, I get a head or tail. The second time I toss it, again I get a head or tail. Tossing it the first time and tossing it the second time are independent events. There is no link between the two. Whether you get a head in the first time or a tail, second time also you get a head or tail only. It's not going to be influenced by the first throw. Okay, so every trial is independent. Every trial is independent. This is the second important condition. to apply binomial distribution. So the first is the number of trials is too large but finite, and the second is every trial is independent. The third is every, note down with me, every event, or don't write every, events, okay, write down, events are mutually exclusive and exhaustive. Events are mutually exclusive and exhaustive. Okay, so what do you mean by events being mutually exclusive? Okay, if I say mutually exclusive, it means in the first time we are going to throw, we are going to get a head or tail. Second time we are going to throw, we are going to get a head or tail. Is there anything common in terms of the event? There is nothing common. They are totally separate events. There is no overlapping. So when I say events are mutually exclusive, it means when mutually exclusive means when nothing is common between two events. Okay, nothing is common between two events. For example, P of A, probability of A union B. Okay, the union means the combination of the two is equal to P of A plus P of B. In other words, P of A intersection B is not there. It is 0. Okay, so that is what is meant by mutually exclusive events. Okay, what do you mean by exhaustive? Exhaustive. When I say exhaustive, I mean that when events are complete in themselves to form the what? Universe. Universe means the total set of all events. Okay, so P of A union B, again we are talking about P of A union B, that is equal to 1. That is equal to 1. Where all we can apply binomial distribution is what we saw right now. And we saw 3 cases, 3 conditions. The first condition is where the number of trials is too large but finite. The second is every trial is independent. Every trial is independent. The third is events are mutually exclusive and exhaustive. Events are mutually exclusive and exhaustive. Now let us move on to the fourth condition. Okay, fourth condition. Please make a note of the condition first and then I will explain to you in a step-by-step manner, in a detailed manner. Every trial has only 2 outcomes. Occurrence of one will be called success, indicated by P, and occurrence of another is called failure, indicated by Q. Every trial has only 2 outcomes. Occurrence of one is known as success, indicated by P, and occurrence of the other is called failure, indicated by Q. And I will also put this in the form of a relationship. Probability is equal to NCR into P to the power R into Q to the power N minus R. NCR into P to the power R into Q to the power N minus R. These components, which of these terms mean, okay, where N is equal to the number of trials, okay, R is equal to number of success, required, okay, number of success required, and P is equal to probability of success in one trial, and Q is equal to probability of failure in one trial. Okay, in some books they also refer to R as X, which is also okay. Okay, so P is equal to NCR into P to the power R into Q to the power N minus R. And here N is equal to number of trials, R is equal to number of success required. P is equal to probability of success in one trial, and Q is equal to probability of failure in one trial. Fourth condition, let me give you a simple example, okay? A coin is tossed 10 times. What is the probability of getting 6 heads? Coin is tossed 10 times. What's the probability of getting 6 heads? So here N is the number of trials. So what is N here? N is 10. R is the number of success required. Success is getting a head. So we need to know how many heads do we need? 6 heads. 6 heads. 6 is R. R is equal to 6. What is the probability of getting a head? P is the probability of success in one trial. In every trial, we will get a head 0.5 or half the time, or 1 by 2. Same way, in every trial, what is failure? Not getting a head. Not getting a head means getting a tail. So that is also equal to 1 by 2. Okay, so now let me do the probability required. P of 6 heads is equal to P of 6 heads is equal to NCR. N is 10, C, R is 6 into 1 by 2 to the power N. Sorry, 1 by 2 to the power R. R is 6, and Q is 1 by 2 to the power N minus R, which is 10 minus 6, which is 4. So this is the answer. 10C6 into 1 by 2 to the power 6 into 1 by 2 to the power 4. Which is very obvious, is that P plus Q is equal to half plus half, which is equal to 1. So this is P plus Q is the union, and that is equal to 1. What are they saying here? It should be equal to 1. So it is exhaustive. Mutually exclusive means nothing is common. When you get a head, you get a head. When you get a tail, you get a tail. There is nothing in common between the two. We are talking about one particular event of throwing a coin. Okay. The solution: 10C6 into half 1 by 2 to the power 6 into 1 by 2 to the power 4. This is equal to 10 factorial by 6 factorial into 10 minus 6 factorial, which is 4 factorial, into half to the power 6 into half to the power 4. This is equal to 10 into 9 into 8 into 7 into 6 factorial, and we write this as 4 factorial into 6 factorial. Here factorial and 6 both are same. So we can cancel it. Number and factorial should be same. Okay, then this is 10 into 9 into 8 into 7 by 4 into 3 into 2. 4 into 2 is 8, 3 into 3 is 9, which is 210 is the number. Here half and half both are, the base is same. So base is same, power is different, means we have to add the power. Okay, as we learnt in the chapter indices. So this is 1 by 2 to the power 10. So 210 into 1 by 2 to the power 10 is my answer. Okay. problems in binomial distribution, we shall be going through the properties of a binomial distribution. So the first property which we'll be looking at is in the case of mean. Okay, so mean in case of a binomial distribution, the mean is equal to n into p. N into p. Okay, so let's write down this first. Mean is equal to np. Mean is equal to np. Okay, so in the previous question, let us take the previous question. N is 10 and p is half. Okay, so in that question, the mean will be n is 10, p is half. Mean is equal to 10 into 1 by 2, which is 5. Mean, in the case of a binomial distribution, we will refer to the mean as this symbol, mu symbol. So mu is equal to 5 in this case. Okay. The second property is regarding the variance. It is the variance of the binomial distribution. Formula for the variance is NPQ. Okay, NP is the mean, NPQ is the variance. Okay, in our question, let us see what is the variance. N is 10, P is half and Q is also half. It is 10 by 4, which is 2.5. So the variance is equal to NPQ, which is equal to 2.5. If you want to pull out the standard deviation, you need to go in for the square root of the variance, which is square root of 2.5, which gives me 1.58. This is the standard deviation. Two important concepts here which you need to memorize are: the first concept is variance is always less than the mean. Variance is always less than the mean. Okay, the first concept, and it is also a proven exam question. Okay, be very thorough. Variance is always less than the mean. You can try any question and see, you will always get a variance which is less than the mean. Second is also equally important. Variance will be highest when variance will always be highest when P is equal to Q is equal to 0.5. When P is equal to Q is equal to 0.5, the variance will always be highest. So when your P is equal to Q equal to 0.5, the variance will be NPQ, which is N into P. We can write it as 1 by 2 into Q, which is N by 4. Okay, so when N by 4 is the variance, at that point your variance will be the highest in that particular scenario. So please make a note of this in your formula booklet. You will be having a formula booklet in which you will mention all the important concepts, important formulae, everything which is required for ready referencing. So please make a note of these 2 points in the formula booklet. It is most important. If you miss it out and you end up getting a question, then it will be a matter of pity, because you've learned this and you should never forget it. So please make a note of it in your formula booklet. Okay. So we saw two properties. First is the mean, second is the variance. Now we go ahead with the third property, which is the mode. Okay, the mode of the binomial distribution. Now the mode is equal to, the value of the mode is n plus 1 into p. N plus 1 into p. In this particular scenario, there can be two cases. Okay, in the case of mode computation, you can have two cases where, please pay close attention. Whenever you calculate the mode value by using n plus 1 into p, you can have two situations. The first situation is n plus 1 into p will be an integer. n plus 1 into p will be an integer. What do you mean by integer? It is a non-decimal number. Non-decimal number is called an integer. So for example 4, 5, 6 like that. Okay, if your n plus 1 into p is an integer, then you will end up having two modes. How? I will tell you. Before that, first write down that n plus 1 into p can be either two cases. One case can be either n plus 1 into p being an integer, in which case that particular distribution is bimodal. Bimodal means having two modes. Okay, having two modes. And what are the two modes? And why does it have two modes? Because whenever you have an integer, you have to pull out the mode in this manner. The first mode will be n plus 1 into p. Second mode will be n plus 1 into p minus 1. Okay, for example, if your n is equal to 7, p is equal to 1 by 2. Okay, first you have to compute. The question will be calculate the mode. So first step for you to do is to calculate n plus 1 into p, which is equal to 7 plus 1, 8 into 1 by 2, which is 4. It is an integer, correct? So when it is a non-decimal number, if it is an integer, then you will have two modes. One mode will be this n plus 1 into p will be one mode, and that number minus 1, which is 3, will be the other mode. These are the two modes. Okay, so this is the case where you will solve if it is n plus 1 into p being an integer. The second instance is n plus 1 into p. N plus 1 into p is a decimal. Decimal means non-integer is a decimal. Non-integer. If that is the case, then it is a unimodal distribution, which means it is having single mode. Okay, so for example, you can say n is equal to 10 and p is equal to 1 by 3. Okay, so n plus 1 into p, the first step is to calculate n plus 1 into p, that is n plus 1, which is 11 into 1 by 3, which is 3.67. Now this is a decimal. How do you calculate the mode? Can you say the mode is 3.67? No, that's not the method you solve it. Okay, first you calculate the n plus 1 into p value. After calculating n plus 1 into p value, what is your mode? Your mode is equal to the greatest integer in n plus 1 into p. This is the mode value, greatest integer in n plus 1 into p. So that is going to be, in our example here, it is going to be 3. It is going to be 3. Only one mode. Okay, calculation of mode is a very important concept. First, for calculation of mode, you need to know the formula, which is n plus 1 into p. The first critical formula we should remember is n plus 1 into p. Then you can have two cases where this can be an integer, this can be a non-integer. If it is an integer, then you have two modes. So one will be the n plus 1 into p value itself, and one will be that value minus 1. Then if it is not it is a non-integer, means it is a decimal, then it has only one mode. You have to take the greatest integer in n plus 1 into p. That is all. That is the mode. Okay, make a note of this quickly. Exam questions. Okay, practice questions. Note down the questions. A coin is tossed 8 times. What is the probability of getting four heads? At least 4 heads. second one. Okay, third one, at most 3 heads. Okay, probability of getting 4 heads, then at least 4 heads, and the third is at most 3 heads. Okay, so let us take the solution. Some basic numbers let's note down here. Coin is tossed 8 times, n is 8. What is the first part is r is equal to 4. Okay, r is 4 means we need to get exactly 4 heads. So the probability is equal to, and one more thing, coin tossed means p is half and q is also half. P is equal to NCR into p to the power r into q to the power n minus r. Okay, if you forget your formula, no one can save you. So please make a note of this and remember the formula. Okay, don't go wrong in basic things. So P is equal to N 8C4 into half to the power 4 into half to the power 8 minus 4, which is also 4. So that is the answer for the first part. Okay, so depending on what is given in the choices, you need to simplify it. If this itself is given in the solution as one of the options, you go in for that. Don't blindly solve the question without seeing the options. Okay, if the answer is given in a more simplified manner, then you simplify this and you approach that, and then you have to select the answer. Okay, the next subdivision is part B. At least 4 heads. At least 4 heads means you will have to have at least minimum 4. So R is going to be greater than or equal to 4. What are the options here? Possibilities is it's tossed 8 times means R can be either 4, R can be 5, R can be 6, R can be 7 and R can be 8. These are the options. And P is 1 by 2, Q is 1 by 2. Okay. So these are the options. Greater than or equal to 4. I mean P of R equal to 4 plus P of R equal to 5 plus P of R equal to 6 plus P of R equal to 7 plus P of R equal to 8. So these are the possibilities we need to answer. Okay, so for everything we have to apply the formula NCR into P to the power R into Q to the power N minus R. So it will be N is 8, C, in the case of R equal to 4, we have to have 4 here, into half to the power 4 into half to the power 4, plus NCR 8C5 into half to the power 5 into half to the power 3, because 8 minus 5 is 3, plus 8C6 into half to the power 6 into half to the power 2, plus 8C7 into half to the power 7 into half to the power 1, plus 8C8 into half to the power 8 into half to the power 0. This is the basic level of substitution. Then we can take this as 8C4 into half to the power 4 plus 4, common base, add the power 8, plus 8C5 into half to the power 8. You will get 8 only because we have taken that is the formula is devised in such a way that total will be equal to 8. 8C6 into half to the power 8 plus 8C7 into half to the power 8 plus 8C8 into half to the power 8, which is going to give me half to the power 8. I take out common, okay, and then I take 8C4 plus 8C5 plus 8C6 plus 8C7 plus 8C8. Division. The third subdivision is at most 3 heads. At most means at max, okay, 3 heads. So when I say at most 3 heads, it's like the opposite of at least. At least means minimum, it should have 4 or whatever. Here at most is maximum, it can have only 3 heads. So that is going to be equal to P of R is going to be less than or equal to 3. It cannot exceed 3. Okay, that is equal to P of r equal to 0 plus P of r equal to 1 plus P of r equal to 2 plus P of r equal to 3. You see that it is also lengthy, as equally lengthy as the previous portion. Okay, so we have to again sit and calculate all these values. Now also one more thing I want to share with you here. P of r equal to 0 plus P of r equal to 1 plus P of r equal to 2 plus P of r equal to 3 is the solution to our third subdivision, at most 3 heads. Now tell me one thing. P of r equal to 0, okay, P of r equal to 1, P of r equal to 2 plus P of r equal to 3. Okay, this portion of the solution for third part, plus if I add P of r equal to 4 plus P of r equal to 5 plus P of r equal to 6 plus P of r equal to 7 plus P of r equal to 8. This is the whole thing. Okay, if I add everything, I am going to get 1. Is it not? I will get 1, right? Why will I get 1? Because this is the condition of a binomial distribution where the events are going to be mutually exclusive and exhaustive. Exhaustive means the total of all those, union of all those events is going to be 1. Okay, it's going to be 1. So this is nothing but union of all the events. R is equal to 0 is in this end, R is equal to 8 is in the other end. So if I total everything, that is nothing but the union of all the events, okay, within the set. That is going to be equal to 1. Okay, by definition it is equal to 1. Now also tell me one more thing. Do I know what is this value? P of r equal to 4 up to P of r equal to 8. P of r equal to 4 up to P of r equal to 8 is what I calculated in my second step. Is it not? If I calculate 1 minus P of r greater than or equal to 4. Now this portion is nothing but P of r greater than or equal to 4, which is what I did here. If I do 1 minus this P of r greater than or equal to 4, I will get P of r less than or equal to 3. So in this case, in the third subdivision, instead of computing the whole formulae once again with the different substitutes of value, okay, especially if the answer is simplified to a specific number, I don't need to do everything again in this case. I can just take that portion which I calculated in second part and 1 minus that part will give me the answer. If I were to simplify this, for example, 1 by 2 to the power 8, okay, let me calculate. Okay, I will show you for your information. It will be easy for you. Okay, 1 by 2. 1 by 2 is nothing but 0.5. 0.5 into 0.5, that is square, into 0.5 cube, into 0.5 4 times, 5, 6, 7 and 8. It is going to be 0.00391. Here I will simplify 8 factorial by 4 factorial into 4 factorial plus 8 factorial by 5 factorial into 3 factorial plus 8 factorial by 6 factorial into 2 factorial plus 8 factorial by 7 factorial into 1 factorial plus 8 factorial by 8 factorial into 0 factorial. This will be, okay, this would be equal to 0.00391 into here 8 into 7 into 6 into 5 into 4 factorial by 4 factorial into 4 into 3 into 2 into 1. This will get cancelled. 4 and 2 will be 8 and 3 2s are 6. Okay, this is 0.00391. 7 2s are 14, 5s are 70. Okay, this is 70 plus here 8 into 7 into 6 into 5 factorial by 5 factorial into 3 into 2. So this will go, this is 56. Then the third part is 8 factorial by, 8 into 7 into 6 factorial by 6 factorial into 2. This would give me 28. Okay, 28 plus we have completed up to 3. Now the fourth part is 8 into 7 factorial by 7 factorial. This is plus 8 plus this is going to give me, this is 1. 0 factorial is 1 and this is 1. This is plus 1. Okay, so now this is equal to 0.00391 into, I need to add up all these values within the bracket, 70 plus 56 plus 28 plus 9. That gives me 163. This is nothing but 0.637. Okay, now here in the third case, if I just take 1 minus 0.637, I will instantly get my answer, 0.363. Instead of calculating everything again, I will just use this calculation and find out the value required in the third subdivision. Okay, so please make a note of this. This understanding is very important. You have to understand why this is equal to 1 and how you can take out the other value using the first calculated value. If 15 dates are selected at random, what is the probability of getting 2 Sundays? Okay, so the question is saying that if 15 dates are selected at random, what is the probability of getting 2 Sundays? Okay, first tell me one thing. In a week, okay, how many Sundays are there? There is only one Sunday in a week. So in a week, the probability of getting a Sunday is 1 by 7. If I were to put this down, P is equal to 1 by 7. Then what is the probability of not getting a Sunday? That was going to be equal to 1 minus 1 by 7, which is 6 by 7. Okay, so 1 by 7 and 6 by 7. I want to get 2 Sundays. Probability of getting 1 Sunday is 1 by 7. I want to get 2 Sundays. R is 2. So my probability of 2 Sundays is equal to NCR into P to the power R into Q to the power N minus R. N is 15. Okay, 15 C2 into 1 by 7 to the power 2 into 6 by 7 to the power N minus R, which is 13, which is 15 factorial by 2 factorial into 13 factorial into 1 by 49 into 6 by 7 to the power 13. 15 into 14 into 13 factorial by 13 factorial into 2 into 1 into 1 by 49 into 6 by 7 to the power 13, which is 7 and 7, 15 into 1 by 7 into 6 by 7 by to the power 13. Okay, seven into 0.1345, 15 into 0.1345 the whole by 7, that gives me 0.288, which is 0.29. So option will have 0.29 also. Okay, please copy this down. Okay, next question. The incidence of occupational disease in an industry is such that the workmen have a 10% chance of suffering from it. What do you mean by occupational disease? Any particular disease or illness that comes from working in a particular industry. Okay, for example, if you are working in a factory where there is a lot of emission of a particular chemical, then there is a lot of exposure which you get when you work in the factory. That is known as occupational disease. So that is 10% probability. What is the probability that out of 5 workmen, 3 or more will contract a disease? So it's actually quite simple. The probability is going to be 1 by 10 or 10%. So P is 1 by 10. Okay, 5 workmen, if you are selecting 5 workmen, N is equal to 5, R is equal to 3 or more. So R is greater than or equal to 3. Okay, R is greater than or equal to 3. If P is 1 by 10, then Q is equal to 9 by 10. Okay, so now you need to calculate P of R equal to greater than or equal to 3. P of R greater than or equal to 3 is equal to P of R equal to 3 plus P of R equal to 4 plus P of R equal to 5. You have to stop there because we are selecting only 5 workmen. Okay, so this is equal to NCR. 5C3 into 1 by 10 to the power R, which is 3 into 9 by 10 to the power. What is the total number? It is 5. N minus R, which is 2, plus 5C4 into 1 by 10 to the power R. R is 4 into 9 by 10 to the power N minus R, which is 1. Plus 5C5 into 1 by 10 to the power 5 into 9 by 10 to the power 0. This is 5 factorial by 3 factorial into 2 factorial into. Now let me solve this for you and give it. Okay, each level I'll solve it and give you. Okay, you can recheck it. Okay. Zero 0.001 into 0.81 plus 5 factorial by 4 factorial into 1 factorial, okay, into 0.0001 into 0.9 plus 5 factorial by 5 factorial into 0 factorial into 0.00001 into 1. This will give me this is equal to 5 into 4 into 3 factorial by 3 factorial into 2 into 1 into 0.00081 plus 5 into 4 factorial by 4 factorial into 1 into 0.00009 plus 1 into, that is 0.00001. This is going to give me 0.008 plus 0.00045 plus 0.00001. This is equal to 0.0086. Very important question. Okay, so please be very thorough in this question. In this question, your understanding is very important. Okay, it looks like a complicated question, but if you understand it correctly, then it's quite simple. But if you make a mistake in the basic values, then it's gone. Okay, So an experiment succeeds thrice as much as it fails. It succeeds thrice as much as it fails means the probability of success is given as 3x and the probability of failure is x, 1x. So the total number of times will be 4. So the total times it is done, if it succeeds thrice, it fails once. So 3 is to 1. Okay, so therefore R is equal to, not R, P is equal to thrice as often as it fails, 3 by 4. Q is equal to once it fails, 1 by 4. Okay, and R is equal to no success. No success means 0. R is 0 and N is equal to repeated 5 times. So it is 5. So NCR P of R equals 0 is equal to NCR 5C0 into 3 by 4 to the power 0 into 1 by 4 to the power 5 minus 0, which is 5. This is very simple. 5 factorial by 5 factorial into 0 factorial into 1 into 1 by 1024. This is also 1. This is 1. So 1 by 1024 is your answer. Find the probability of success for the binomial distribution satisfying 4p of x is equal to 4 is equal to p of x equal to 2. Other parameter as 6. So the wordings are a bit confusing in this question. Okay. So they're saying that you need to find the probability of success. So p is not given. They're asking you to find out. Okay. And r is given in the one case it's given as 4 and another case it's given as 2. So r is again not a problem. We have r. But what are the other parameters which are not there? Q is not there and N is not there. R is given. 2 scenarios are given. P is not given. That is the question asked to find out P, probability of success. That is nothing but P. Now the other parameter is given as 6. When they say other parameter, how do you know what it is? So apart from P, apart from R, we have Q and N. Now Q or P cannot be more than 1. Okay, because P plus Q itself is 1. Okay, the maximum probability is 1. The total is 1. So 6 has to be nothing but N. Okay, so let's equate this. So we have found out that N is equal to 6. Now 4p of x equal to 4 means 4 into 6c4 into p of 4, p to the power 4 into q to the power 2. This is equal to 4 into this is equal to p of x equal to 2. So NCR again is 6c2 into p to the power 2 into q to the power 4. Now let us see this. NCR is equal to NCR minus 1. This is a property which we learned. So 6c4 is equal to 6c2. Once you find the value, it is enough. Okay, 4 into 6 factorial by 4 factorial into 2 factorial into p to the power 4 into q to the power 2 equal to, again the same thing, 6 factorial. Now this is equal to 6 into 5 into 4 factorial by 4 factorial into 2 into p square q to the power 4. Okay, so this is nothing but 15 by 2. Okay, so 4 into 15 by 2 into p to the power q square is equal to 15 by 2 again into p square q power 4. This gets cancelled. Four p square is equal to q So we have got 4p square equal to q square. Now we know that q is equal to 1 minus p. So 4p square is equal to q square. We can rewrite as p square is equal to 1 minus p the whole square. 4p square is equal to a square minus 2ab plus b square. So 4p square minus b square plus 2p minus 1 equals 0. P square plus 2p minus 1 equals 0. Three p square plus 3p minus p minus 1 equals 0. 3p into p plus 1 minus 1 into p plus 1 equals 0. 3p minus 1 into p plus 1 equals 0. Now p is equal to minus 1 or p is equal to 1 by 3. P cannot be equal to minus 1 because probability cannot be negative. So therefore p is equal to 1 by 3. If p is equal to 1 by 3, q is equal to 2 by 3. This is my answer. For which mean and standard deviation are 6 and 2 respectively. So for a binomial distribution, mean is mu, which is np, which is equal to 6. Standard deviation is going to be square root of npq, which is equal to 2. Let us square this. npq is equal to 4. Now np is equal to 6. 6q is equal to 4. Q is equal to 4 by 6. Q is equal to 2 by 3. Okay. N into P is equal to 6. N into 1 minus Q is equal to 6. N into 1 minus 2 by 3 is equal to 6. N into 1 by 3 is equal to 6. N is equal to 6 into 3, which is equal to 18. So therefore, I write the answer here. P is equal to 1 by 3. Q is equal to 2 by 3 and N is equal to 18. This is my answer. Binomial distribution for which these values are applicable. Okay, so what is the binomial distribution? It is NCR. Okay, so what is N? It is 18. 18CR. Okay, so R is not known. Okay, we keep it as R itself into P. 1 by 3 to the power R into 2 by 3 to the power N minus R. So n is 18, we can say 18 minus r. This is the binomial distribution. So you have to leave r as it is and calculate the others. Substitute the others. Distribution for which mean and standard deviation are 10 and root 5 respectively. Okay, so mean is mu, which is np, which is 10. Then the standard deviation is equal to square root of npq, which is equal to root 5. So npq is equal to 5. Now np is 10. 10 into q is 5. Q is equal to 1 by 2. If q is 1 by 2, p is also equal to 1 by 2. Okay, so now we have to calculate n. Okay, npq is 5. Okay, np, we'll take np. np in n into p is 10. N into 1 by 2 is 10. So n is equal to 20. Okay, now the mode is equal to n plus 1 into p. Mode, always we have to take this value n plus 1 into p, which is equal to 21 into p is 1 by 2, which is 10.5. Now we are getting a non-integer. This is nothing but a non-integer. Okay, so if it is a non-integer, this n plus 1 into p, then mode is equal to what? Mode is equal to 10. We take the greatest integer, n, which is 10. Mode is 10. Greatest integer. Okay, so with this we come to the end of the binomial distribution chapter. Okay, hopefully you will all be thorough with this now. Please solve these questions once again by yourself and do try all the other questions given as well, and we'll then go on to the next set of subtopics in the next few lectures. Okay, now we'll be continuing with our theoretical distribution, and we are going to do Poisson distribution. Okay, so Poisson distribution is also quite simple. Okay, very easy topic, very small topic. So let us first go into the topic. Simon Dennis Poisson. Okay, this is by Poisson distribution is by Simon Dennis Poisson. Okay, now here I will revisit binomial for a minute. Okay, in theoretical distribution, we first saw what is meant by binomial distribution, in which we saw two things, which are n and p. Okay, n is the number of trials and p is the probability of success. Okay, so probability of success in one trial. Now here what happens sometimes, see, binomial distribution is definitely there to help us in handling bigger numbers. Okay, but at the same time binomial distribution also has certain limitations. What happens if the number of trials is too large? That is, it tends to infinity. And if what happens if the probability of success is very small, this tends to, we say it tends to 0. So if this is the case, then we cannot use binomial distribution. We have to go in for a better method. The situations which we are seeing now, the first situation was when we toss a coin once, twice or thrice, wherein we use the normal method to calculate. We do it in the regular manual way. One by one we calculate. But sometimes the number would be very big, like 20, 30, 40. So in those instances we can use binomial distribution. But what happens if the number of trials is too large and the probability of success is too small? And also here also the trials are independent. So trials being independent is part of this condition. Trials are independent. Trials are independent. So in this circumstance, we will go in for what is known as the Poisson distribution. Okay, we'll go in for the Poisson distribution. Under Poisson distribution, we will calculate the probability with the help of this formula. E to the power minus m into m to the power r divided by r factorial. Okay, let us see what each one is one by one. Here e is the exponential function. And what is m? If you recall, in binomial distribution, we learnt that the mean is equal to np. This is what we denote as m. This is nothing but the average. And e to the power minus m into m to the power r by r factorial. So here we will use that m as equal to np. Okay, but this should be used only when the number of trials is too large and the probability of success is very small. Under this, where m is equal to average and r is equal to number of successes required. Okay, make a note of this. We'll proceed. Do the properties of a Poisson distribution. The first one is about the mean is m. Mean is m. Then the variance is m and the standard deviation is root m. Okay, then we come to the mode. Mode is also m, and there are two cases here. If it is the value is an integer and if it is a non-integer. If it is an integer, then it is bimodal. Distribution is bimodal. One is m and one is m minus 1. If it is a non-integer, it is unimodal, and that is the greatest integer in m is the mode. Okay, so make a note of all these points. These are also important, and we'll go ahead with solving the problems. To understand better, I will give you this list. Okay, applications of Poisson distribution. And please be informed that you can get tested in the MCQ from this area also. So they can ask you what are the applications, and you will also be finding it simple to identify where you have to use Poisson with this list. Okay, so you can get theory question also, and you can get a practical question where you have to apply this concept. So whenever there is a question of which is a question on number of printing mistakes or errors per page of a large book. So large book is the clue here, large book and number of printing mistakes. Then one more case is number of road accidents. Number of road accidents on a busy road per minute. Okay, these are all cases where the p will be very small and the number will be very big. Okay, the numbers in question will be very big. Then the third is number of radioactive elements per minute in a fusion process. Make a note of all this, write along with me. Please don't show any hesitation in writing when you're in your CA study. You have to always keep writing. Writing practice is very important. Okay, and then the last one is, now it is an illustrative example, but you can get tested from these only for the CA foundation level. number of demands per minute for a health center. Okay, these are the applications, so please go through this. For that, in the question, E value will normally be given. Okay, E value will be normally given, but if the E value is not given, then please remember this value, memorize it. Okay, 2.71828. Now I want to share something with you, okay, before starting this problem. Okay, for Poisson, even for binomial, the question looks intimidating, but when you start solving it in a simple manner, it becomes very easy. Okay, so don't get frightened by seeing the question. Calmly think of the formula and then see what is given, apply what is given, substitute the values, and you will get the answer. Okay, and let us see this question. Find the mean and standard deviation in a Poisson variate where P of x equal to 2 is equal to P of x equal to 3. Okay, here first you will recollect the formula. P is equal to e to the power minus m into m to the power r by r factorial. Okay, so here P of x is equal to 2 is e to the power minus m into m to the power r is 2 by r factorial, that is equal to e to the power minus m into m to the power 3, where because r is 3 by 3 factorial. Here I can cut out this and I will cut out this. So I get 1 by 2 factorial into 3 factorial is equal to m. M is equal to 3 into 2 into 1 by 2 into 1. M is equal to 3. This is the answer. Is equal to root m, which is equal to root 3. So standard deviation is equal to root 3. So that is also done. Copy this down. Next question. If probability is 1 minus e to the power minus 2.7, what is the mode of the distribution? First of all, you know that the probability is equal to e to the power minus m into m to the power r by r factorial. So here e to the power minus m means m is equal to minus m is equal to 2.7. Okay, because this m is in the power. Okay, here the mode, coming back to our mode is equal to m. So if the mode is a non-integer, then the greatest integer in m will be the mode. So here mode is equal to the greatest integer, and that is equal to 2. So mode is equal to 2. That's it. Take down this question. Standard deviation of a Poisson variate is 1.732. What is the probability that it lies between minus 2.3 to 3.68? Okay, so standard deviation is equal to 1.732, which is equal to root m. So m is equal to, you have to square 1.732. If you square 1.732, you get 3. Okay, now m is equal to 3. This is what we have found out till now. Now look at the question. They are asking you to tell the probability that it lies between minus 2.3 to 3.68. Whenever you talk about probability of anything, okay, could be getting a head, getting a tail, getting a 5 on a dice, getting a red card, whatever it is, the probability can either be, it can be any number like 1, 2, I mean you can get success, or you cannot say you have a negative probability like minus probability, or I have a minus 5 probability. That is not possible. So what you have to understand is probability that is there, this probability which we are learning has to always be more than the success has to always be more than 0. Okay, so only then we can have this as a success. So this r cannot be in points, it has to be in integer, and it has to be more than 0. It has to be integer and it has to be more than 0. That is the first thing we have to know. Value cannot be negative, and r value cannot be in decimal. It cannot be a non-integer. I cannot say I have a probability of, like, I'm getting number of successes 1.7, 3.2, like that. You cannot have that as a case. So r has to be greater than 0. So they are asking you to find out p of r equal to 2.3, minus 2.3 to 3.68. So it lies under minus, within minus 2.3, less than 3.68. So in this case, how you would say is p of minus 2.3 less than r less than 3.68. This is actually equal to this probability of negative is ruled out. Okay, what is ruled out? Negative is ruled out, non-integer is ruled out. So you have to take only the integers between 0 and 3. Okay, so you can say this is equal to p of r equal to 0 plus p of r equal to 1 plus p of r equal to 2 plus p of r equal to 3. We cannot go to 4 because it is stopping at 3.68. And so you have to say p of r equal to 0 is e to the power minus m into m to the power 0. Here m is 3. So you can substitute 3 here. P to the power minus 3 into 3 to the power 0 by 0 factorial plus, okay, plus e to the power minus 3 into 3 to the power 1 by 1 factorial plus e to the power minus 3 into 3 to the power 2 by 2 factorial plus e to the power minus 3 into 3 to the power 3 by 3 factorial. This is equal to, we will take out e to the power minus 3 common. This is equal to 1. 3 to the power 0 is 1 by 0 factorial is also 1 plus 3 by 1 plus 9 by 2 plus 27 by 6. Let us simplify this. 6 plus 18 plus 27 plus 27 equals e to the power minus 3 into this is equal to 7173. This is e to the power minus 3 into 13. You have to substitute here. This is equal to 2.71828 to the power minus 3 into 13. The answer for that would be 0.65. You can solve and say it is 0.65. If p of x is equal to 2 is equal to 9 into p of x equal to 4 plus 90 into p of x equal to 6, what is the standard deviation of the Poisson variant? Okay, so here let us first substitute in the formula. E to the power minus m into m to the power r, which is 2, by 2 factorial is equal to 9 into e to the power minus m into m to the power 4 by 4 factorial plus 90 into e to the power minus m into m to the power 6 by 6 factorial. E to the power minus m into m square by 2 is equal to e to the power minus m into m to the power 4 into 9 by 4 into 3 into 2 into 1 plus 90 into m square by 6 into 5 into 4 into 3 into 2 into 1. This will be, here e to the power minus m gets cut out, m square will get cut out here, and it is 1 by 2 equals m square into 9 will go 3 times here, 3 by 4 2s are 8, 3 by 8 plus here you have 90. Now this is 6 into 5 is 30, 33s are 93. So this is m square by 8. This is the simplification here, and I can solve this. I can open the bracket. 1 by 2 is equal to 3 by 8 m square plus 1 by 8 m to the power 4. Here I can cut out like this. So before that, 1 by 2 equals, this 1 by 2 equals 8 3m square plus m to the power 4, and 2 4s are 8. So 3m square plus m to the power 4 equals 4. Okay, 3m square plus m to the power 4 equals 4. Let x square be, let m square be equal to x. So 3x plus x square equals to 4. X square plus 3x minus 4 equals 0. X square plus 4x minus x minus 4 equal to 0. X into x plus 4 minus 1 into x plus 4 equals 0. So x plus 4 into x minus 1 is equal to 0. X is equal to 1, x is equal to minus 4. Now x is equal to minus 4 is not possible. So x is equal to 1, m square is equal to 1, then m is also equal to 1. Then this is standard deviation is equal to 1. So this is the solution for the question. Between 9 am and 10 am, average number of phone calls per minute coming is 4. Find the probability during one particular minute that there will be no phone calls, at most 3 phone calls. Okay, so first let's take part A. The average number of phone calls coming per minute is 4. M is equal to the average, which is 4. Okay, so R is equal to no phone call, means R is equal to 0, is equal to P of R equal to 0 is equal to e to the power minus 4 into m, which is 4 to the power 0 by 0 factorial, which is equal to e is 2.71828 to the power minus 4 into 1 by 1, which is 2.71828 to the power minus 4. This you have to take with the help of calculator. You should do 1 by 2.71828. You do 4 times, you divide it, and your answer will be 0.01831. Okay, you do it and see, you will get this answer. Part B is at most 3 phone calls. At most 3 means maximum 3. So it could be R equals 0 plus R can be equal to 1 plus R can be equal to 2 plus R can be equal to 3, but not more than 3. So this is equal to, now m is equal to 4. E to the power minus 4 into 4 to the power 0 by 0 factorial. This we found out in the first part, plus e to the power minus 4 into 4 to the power 1 by 1 factorial plus e to the power minus 4 into 4 to the power 2 by 2 factorial plus e to the power minus 4 into 4 to the power 3 by 3 factorial into 1 by 1 plus 4 by 1 plus 16 by 2 plus 64 by 6. We have to simplify e to the power minus 4 into 1 plus 4 plus 8 plus 32 by 3, which is e to the power minus 4. You take LCM. E to the power minus 4 into so the answer for this is 0.43. 0.43. If 2% of electric bulbs manufactured by a company are known to be defective, what is the probability that a sample of 150 bulbs taken from the production process of that company would contain exactly one defective bulb? Second part, more than 2 defective bulbs. You are given e to power minus 4 is 0.018316. Now before that, first you should know certain things with regard to selection of Poisson distribution to solve the answer. How to ascertain that a question is to be solved using Poisson distribution. Now there are certain like clues which you can adopt. Okay, the first is the question itself will mention, question specifies Poisson. Second is e value is given. If e value is given, then again you know that it is Poisson distribution. Now there could be a question without any mention about Poisson and without any e value. In that case, you should see the observations in the question. If the number, like the n value is very large, if the n value is very large, like in this question 150 is a sample, okay, n value is very large and the probability is very small, like here 2% is a very small number, 0.02. So this is one more way in which you can know that it is going to be Poisson. And another thing is here n can be taken as more than 50. So in that case you apply Poisson without thinking. Okay. Now in this question, let us first take the details given here. Probability is equal to 2 by 100, which is 0.02. Okay, probability is very low. So this is very low. This extends to 0 and n value is 150. This is very large, too large, extends to infinity. Here it's not extending to infinity, but it's still very large. Okay, you will apply Poisson. And exactly one defective bulb means P of R equal to 1. This is equal to e to the power minus m. But what is m? We don't know what is m. So let us find the value of m here. M is equal to NP. Okay, average NP. N is 150 into P, 0.02. This is equal to 3. Okay, so e to the power minus 3 into m, 3 to the power 1 by 1 factorial, which is equal to, here they are saying e to the power minus 4 is equal to, the value is given. Okay, so we will not rely on this value, we will find out ourselves. Okay, so this value is not going to be relevant for us. 2.71828 to the power minus 3 into 3. Okay, so let us calculate. So this value, when you calculate with your calculator, is 0.049 into 3, which is almost 0.15. This is the answer. second portion is asking you to compute what is the probability that that sample would have more than 2 defective bulbs. So when a sample has more than 2 defective bulbs, this is part B. This is P of R more than 2. More than 2 means the next integer is 3. You cannot have 2 point something. So it has to be P of R equal to 3 or more. So it is asking you to say what is P of R equal to 3 plus P of R equal to 4 plus P of R equal to 5, so on and so forth up to P of R equal to 150. So here it is talking about the exhaustive list up to 150. That is, it should not be less than 3. It should not be 2 or below. It should be 3 or above. This is what they are asking you to compute. But this computing this is little too much, right? You cannot do this. You cannot compute one by one. It's going to be cumbersome. The very point of a Poisson distribution is defeated. So what you can do in this case is this whole thing probability will be equal to 1. Okay, so this probability of the whole thing will be equal to 1. So what you need to remove is you have to remove. Now the whole thing means I say P of R equal to 0 plus P of R equal to 1 plus P of R equal to 2 plus this lot. This equals to 1. So here you can simply pull out the first part. P of R equal to 0 plus P of R equal to 1 plus P of R equal to 2. If you pull this out, you can just find 1 minus this to get the other portion. Okay, so let us compute e to the power minus m. What is m? M is 4. M is 3. So e to the power minus 3, okay, into 3 to the power 0 by 0 factorial plus e to the power minus 3 into 3 to the power 1 by 1 factorial plus e to the power minus 3 into 3 to the power 2 by 2 factorial. Now this we have to do 1 minus this value. 1 minus this value will give me the answer which I need. Okay, so let me simplify it this side. Okay, 1 minus e to the power minus 3 into 1 by 1 plus 3 by 1 plus 9 by 2. 1 minus e to the power minus 3 into 2 plus 6 bar plus 9. This is 1 minus e to the power minus 3 into, we will simplify this here. Now e to the power minus 3 is equal to 0.049. So 1 minus 0.049 into 8.5. 1 minus this number is 1 minus 0.4165. This is equal to 0.58. Last question. Manufacturer of a certain electronic component is certain that 2% of the product is defective. So probability is equal to 0.02. He sells the components in boxes of 120. So N is equal to 120 and guarantees that not more than 2% in any box shall be defective. Find the probability that the box selected at random would fail to meet the guarantee. So what we are trying to find out is, he says that not more than this 2% shall be defective. So M, we have to first find the average. In any case of Poisson, we have to find the average. Here the number is very large and E value is given, so it is a clue that it is Poisson. M is equal to NP, which is equal to 120 into 0.02. This is 2.4. M is 2.4. Here you have to find out the probability that the box selected at random will fail to meet the guarantee. Okay. When would the guarantee be failed to be met? When will the guarantee be failed to be met? When the defectives exceeds 2%. They are saying that not more than 2% is defective. If the defectives is more than 2%, then the guarantee will be failed. So at that point of time, if m, what is there, that m is not equal to 2.4, if m is more than 2.4, then the guarantee will be failed to be met. If m is more than 2.4, then p cannot be 0.2. So if m is more than 2.4, it means the probability has increased. So if it could be more than 2%, means 3%, 4%, anything which is more than 2%, if you multiply with 120, you will get something which is more than 2.4. So you are supposed to find p of r greater than 2.4. So p of r greater than 2.4 is equal to p of r equal to 3 plus p of r equal to 4 plus etc up to p of r equal to 120. But you cannot find such a big number like this. So what you can do is, you can say that 1 minus p of r equal to 0 plus p of r equal to 1 plus p of r equal to 2. If you find this value, you will get what is the answer for the question. So 1 minus, we will put a bracket here, e to the power minus m is 2.4, e to the power minus 2.4 into m, 2.4 to the power 0 by 0 factorial plus e to the power minus 2.4 into 2.4 to the power 1 by 1 factorial plus e to the power minus 2.4 into 2.4 to the power 2 by 2 factorial. This would give the answer to our question. So you can say 1 minus e to the power minus 2.4 into 1 by 1 plus 2.4 by 1 plus 2.4 square by 2. This is equal to 1 minus 0.0907 e value into 1 by 1 plus 2.4 by 1 plus let's solve for this. 2.4 into 2.4 by 2, 2.88 by 1. This is 1 minus 0.0907 into 1 plus 2.4 plus 2.88, which is 6.28. So this into 0.0907 is 1 minus 0.5695. This is equal to 0.43. This is the answer. So the answer to this question is 0.43. Now, first of all, you have to know that normal distribution is a bell-shaped curve. Okay, let me show you the curve. Okay, it is going to be like this. It's a bell-shaped curve where the midpoint, this midpoint is the point where you have the mean, median and mode, and all three are equal. All three are equal. We commonly denote it using the symbol mu. Use the symbol mu. Okay, this is x bar, which is median, which is mode, that is a midpoint, and it is equal to mu. Okay, first thing, this minus infinity and this is infinity. Okay, this is the basis. We can solve basic questions using this basis. The total area under the curve is equal to 1. Okay, total area under the curve is 1 minus infinity to mu, that is this mean, this portion is equal to 0.5, and infinite mu plus mu 2, that is mu to infinity is also 0.5. If you total these two, you get 1. So minus infinity to mu, the midpoint is 0.5, and mu to infinity is also another 0.5. Total is 1. In which you learned the formula in which the exponential function will go like e to the power minus 1 by 2 into x minus mu by standard deviation the whole square. In that, the x minus mu by standard deviation, this particular portion is called z. We denote this by the term z. Z is equal to x minus mu by standard deviation. X is the required number of successes, or the required value. Mu is equal to the mean, and this is the standard deviation. Okay, make a note of all this. Z here. What is Z? Z is the value that represents the area. Is Z equal to the area then? No, Z is not equal to the area. Z is just the value that represents the area. Okay, let's take some questions based on this first initial concept. Okay, the mean is given as 12, standard deviation is 4. Find the probability of x greater than or equal to 20, given that Z of 0 to 1 is equal to 0.3413 and Z 0 to 2 is equal to 0.4772. Okay, let us begin to start the question. So first we will write down the formula for Z. This is an area based question, so we will write the formula for Z, which we know very well. It is x minus mu by standard deviation. Okay, the second thing is to calculate the Z value. Okay, here x is equal to, let me write down the values given. X is equal to, we will take it as 20. We are asked to find out the probability of x greater than or equal to 20. The number we choose from that is what is available. 20 is available, so 20 is the value of x. Then the mean is equal to 12. Mean is 12 and standard deviation is 4. So Z value is equal to 20 minus 12 by 4, which is equal to 8 by 4, which is equal to 2. So Z is equal to 2. Let us take the diagram. Okay, let us take the graph here so that we understand it better. Okay, I'm going to draw the graph here. This midpoint is the mean, which is 12, and 20. Okay, the left hand side of the midpoint, the mean is going to be less than 12. So if 12 is the midpoint, 20 comes beyond the midpoint. So let us put a dotted line here and put this as 20. What is 20? Why are we taking 20? Because we are supposed to find the cutoff beyond 20. X is greater than or equal to 20. So we will first plot this 20. Okay, that is the one thing. Then the next thing we will do is to plot. After plotting 20, what we will do is find out what is the required area. Now the area which is required to be found is P of x greater than or equal to 20. So we have to find out this area. P of x is greater than or equal to 20. This is the area required. Now z is equal to 2. When is z equal to 2? When the x value is 20. When the x value is 20, z is equal to 2. So this means z is 2 here. At the midpoint, z is equal to 0. Okay, this is where we plot it. Z is equal to 0 when the midpoint is given, and here at 20 z is equal to 2. Here between this and this, now we are given the value, the z value. Now we are given the value of 0 to 2, which is 0.4772. So here this 0 to 2, this value is 0.4772. But this is not the value which we need. We need to find out this value. Okay, what did I tell you that about the area? The area between the midpoint, one half of that full curve, the midpoint divides the area into two halves. So this whole area is 0.5. So if I want to find out only this area, then I need to subtract this 0.5, from that I need to subtract this other area. So the area required is equal to 0.5 minus 0.4772, which is going to be 0.0228. Okay, I will repeat once more. The required area for me is this one. Okay, this is the required area of P of x greater than or equal to 20. But I am given the area of P of, that is z of 0 to 2. From between this point and this point, I am given the area. So I know this area, but I don't know what is this area. But I know that the whole of this full curve from the right side of the midpoint, that whole thing is 0.5 area. So I have to do 0.5 minus 0.4772 in order to calculate the area of the required portion. Okay, that is the answer. So this is my answer. This is how I compute the answer. Now I am going to give one more question based on the same numbers. Now I am going to give one more question based on the same numbers. Okay, so I will remove this. Find P of x is less than or equal to 8. X is less than or equal to 8. Okay, here let us first find the z value. Okay, z value is 8 minus 12 by 4, which is going to be minus 4 by 4, which is minus 1. Z is equal to minus 1. So when x is equal to 8, z is equal to minus 1. Let me draw the curve here. Okay, this is z equal to 0, mean is 12. Now I need to first see where x value is. X value falls to the left side where x is equal to 8. And at this value we have found out that z is equal to minus 1. Now we need to know where is the area where x is less than or equal to 8. So x is, now at this point I will draw a dotted line like this. So I need to find out this area. X is less than or equal to 8. This is the area I require. And I am given that the area from 0 to 1 is equal to 0.3413. So I can take that here itself. 0 to 1 is equal to let me use it here, 0.3413, this area. Okay, so the whole thing is 0.5. This whole thing area is 0.5, and this area which I require is equal to 0.5 minus 0.3413. So this answer which I require is equal to 0.1587. Okay, this is my answer. So I have also done for the second part, which is a second question which is given. Let me do the next question here. Okay, so the next section is find the probability of x less than or equal to 16. Okay, so that is what I'm supposed to find here. Okay, so the first thing I will do is to calculate the value of z. Okay, so I will calculate the value of z here. Z is equal to 16 minus 12 by 4, which is 1. Okay, z is equal to 1. Let me plot the graph. Let me plot the diagram of the curve like this. Okay, here this is the midpoint. So at this point the mean is equal to 12 and my 16 falls somewhere here. Okay, x is 16. I will draw the dotted line again. I need to know the area where x is less than or equal to 16. So here I need to know this whole area. What is the area of this portion? Okay, the whole thing I need. Now they have given me in the question, okay, and z here is equal to 0, z is equal to 1. I know that z of 0 to 1, this portion is 0.3413, and this portion whole portion is 0.5. What I need is the area between this and this. For this it is 0.5 and this area is 0.3413. So the required area is equal to 0.4 plus 0.3413, which is equal to 0.8413. This is my required value of area. Okay, make a note of this. Look at the next question. Find P of x equal to 16. Now the answer for this is, when I am giving you not a range but a specific value where I am saying that x is equal to 16. So for example, where is x equal to 16? At this place. Here I don't have any value. There is no range for me to calculate the value. It is only a single point. So the answer for this is equal to 0. The area is equal to 0. The last question here today which I will be discussing is this. Find P of x less than or equal to 16 by x greater than or equal to 12. Here we are using the formula for probability which we learnt in the probability chapter. Here the formula which we learnt is the formula for P of A upon B. P of A upon B, for which the value is P of A intersection B by P of B. Intersection means the common area, common point. So P of A intersection B by P of B. This is the formula for P of A upon B. So let's see how to do the answer for this question. Now look at this question. Mean is 12, standard deviation is 4. The same values. Now we are supposed to find P of x is less than or equal to 16 divided by x greater than or equal to 12. That is the probability which we require. Now the probability which we require is a fraction where numerator and denominators are present, and therefore this is something which is different from what we have done till now. This is nothing but P of A upon B, where P of A upon B is equal to P of A intersection B by P of B. P of A intersection means the common point. For example, this is A, this is B, this is A intersection B. This is the example. This is from your previous chapter of probability. Now let me show you how to solve this question given the two values of z is as is given for the previous questions. Now let me first draw the diagram. Okay, on this diagram the midpoint is the mu, which is 12, and P of A upon B is formula is P of A intersection B by P of B. So in order to find P of A upon B, we have to first consider P of A intersection B. Now before that, A will be 16 and B will be 12. This is the manner in which we will consider this. First we will see where 12 is. 12 is in the midpoint. Okay, so x is equal to 12 is also the same point as the mean. Okay, that is the midpoint. Here z will be equal to 0. Okay, we have learned this before. Z will be equal to 0. Then P of x, that is x equal to 16. I will do the dotted lines here where my x value is equal to 16. Now at this point I have found out that my z value is equal to 1. I have done this in the previous question. So z is equal to 1. So here my 2 points are plotted. X is equal to 12 and x is equal to 16, and the z values are also plotted. Let me first see what is A intersection B. So what is the intersection of these two? First of all, what is P of x less than or equal to 16? P of x less than or equal to 16 is the 16 value falls on the right side here, okay, here. So if P of x is going to be less than or equal to 16, x is less than or equal to 16, that area will be nothing but this area to the left of 16, that is less than or equal to 16. The whole thing is the first part, that is the P of A value. Then what is the area? That is the area which we need for the x less than or equal to 16 parameter. Then what about x more than or equal to, greater than or equal to 12? When I say 12, I mean the midpoint here. If it is more than 12, then it will be here. This is my required area. Okay, this is my required area now. Now the intersection between these two areas, the intersection between the first area and the second area is what I need. So that is nothing but this area. Okay, this is the intersection of the two areas. So the P of A intersection B value is this value which I have shaded in between in red. So for that, how do I find the value? Now this is z equal to 2, z equal to 0 up to z equal to 1. So this value I know it is 0.3413. So this is nothing but 0.3413. Okay, so I will write it down here, 0.3413 by divide by P of B. Now P of A intersection B is 0.3413. P of B is equal to what? P of B. Now B is x greater than or equal to 12. X is greater than or equal to 12 means it is going to be the value to the right side of the graph. It is the value to the right side of the graph. So x more than 12 means it is going to be this area. The whole area is 0.5. This is the area. So this whole area I will shade it in blue. Okay, I will shade it in blue. Try to understand, it is this area, the area to the right of the midpoint. So that is nothing but 0.5. We already know that it is 0.5. So simple, just replace in the formula. So 0.3413 by 0.5. This is my value and I will find it out now. Give me 1 second. It is 0.3413 by 0.5. It is 0.6826. So the answer to this part is 0.6826. This is the way in which we solve this type of question. Whenever you get a probability like the one which I've given, the probability is having two aspects, like fraction. So where I'm giving you P of A upon B, first consider it as P of A upon B equals to P of A intersection B by P of B. You have to recollect the formula which you learnt in probability, and from there you can substitute and find the value. The core concept here is to identify the area, for which you need to use only your conceptual clarity, your understanding. There is no way in which you can memorize this chapter. The only thing which you should memorize in this chapter is the formula of the function and also the properties. So these you should be very thorough. It should be in your fingertips. Apart from that, other things are all based on understanding. So that is the reason this is a tricky chapter, but at the same time it is a very, very simple chapter. Okay, copy this down. Now I'll take a practical question on this. Okay, the same thing which we learnt now. In a sample survey of 500 workers of a factory, the mean wages and standard deviation of wages are found to be 548 respectively. Find the number of workers having wages more than 600, less than 450 and between 548 and 600. First, let us take the first subdivision, P of x greater than 600. Okay, here under this, first let us find out the z value. Our mean is equal to 500. Okay, mean is 500 and our x value, x is equal to 600. And what is the standard deviation? It is 48. So therefore z is equal to x minus mean by standard deviation, which is 600 minus 500 by standard deviation, which is 100 by standard deviation 48, which is going to be 2.08. This is the first step. So we have first of all found the z value. Okay, so therefore z is equal to 2.08. This is my first step which I have to do. Okay, once I find the z value in question, I will just plot that diagram and see. I will plot all this on the diagram. Let me draw the diagram here, rough diagram. Okay, here this is my mean. Mean is 500, and at this point z is 0, and I am going to plot 600 here. 600 means x is 600, and at this point I have found out that z is equal to 2.08. Now tell me how I will compute now. I have to find the area of P of x more than 600. P of x more than 600 means I need to find the area of this portion. I have to find the area of this portion. How do I find the area of this portion? I know that the whole area is 0.5. 1/2 of the diagram, the bell-shaped curve is 0.5. Now I need to find the area of this portion which I have shaded. For that I have to first find out, I have to deduct from 0.5, I have to deduct the area of this portion. Now I'm going to teach you all the simple method. Okay, I'm going to show you how to refer to the value from the z value table, because sometimes you might not get the values in the question. At that time you need to know how to read the table. Okay, so I thought it's better to teach this particular concept so that you're going to be clear in your mind. Okay, now you are supposed to find out the value which I have shaded. For your clarity I will shade it in red and give you, okay, so that you can understand very well. Now I have to find out this value, this area I need to find out. For that I need to first know what is the value of this portion between 0 and 2.08. Okay, for this there is a separate table. Okay, this is the table. Okay, this is the areas under the standard normal probability distribution between the mean and the positive values of z. I have to refer to this table to look at the positive side of z. Okay, here this page. Okay, here the first step is to first consider the z value. Our z value in the question is 2.08. Okay, z is 2.08. Now if z is 2.08, I have to first see where, look at the x value. Okay, x is where we have to refer. Okay, come down under the x column. Here the first column, this one, come down under that. 2, the integer is 2.08. okay, the number is 2.08. it is a non-integer, 2.0. so the first thing which comes to our mind is this 2.0. this we have to go and read the value here. It is 2.0. now how much is left from our z value? 2.08 minus 2.0. we are left with 0.08. so come to the right side and read under 0.08. Come to the right side and read under 0.08. This is 0.08. This column I have to refer. So 2 against 2.0 and the 0.08 both combined together gives me 0.4812. So this is my z value. I have to take the z value. If z value is 2.08, I will come to 2.0 under x column and then go to the remaining portion. What is the remaining portion? 0.08. I have to see under that table, under that column, and club them both and take that value, and that is my z area. So it is 0.4812. It is 0.4812. So this area is 0.4812. Okay, now I know that this area is 0.4812. This area, whole area is 0.5. The remaining area which I need is required area is equal to 0.5 minus 0.4812. So I have to take 0.5 and I have to subtract 0.4812 and I will get 0.0188 as the required area to the right. Where is it required? It is more than 600. That aspect, that area is 0.0188. Till here, are you all clear? So the probability that a worker selected at random, or find the number of workers having wages more than 600. So number of workers with wages more than 600 is 0.0188 into 500. This is my answer, 0.0188 into 500, which is 9.4. But we can't have 9.4, we can't have point in the number of workers answer, so we will say it is 9 workers. We will say it is 9 workers. The next is P of x less than 450. P of x less than 450. Here we have to again calculate the z value. The z value is equal to x minus mean by standard deviation. X is 450 minus mean is 500 by standard deviation is 48. That gives me a negative z value of minus 1.04. This is the value, minus 1.04. Okay, so let me first draw the diagram now. Minus, okay, here this is z equals 0, this is the point of 500, and if I talk about 450, it will be somewhere here. The first thing is to plot the x value. X is 450, at that point z is equal to minus 1.04. So 450 falls to the left side of 500. X value cannot be negative. Be careful, x value cannot be negative. Only the z value can be negative. X is the number of people required, number of successes required. You cannot say I want minus 5 successes, minus 6 successes. So the x value can never be negative. Even if it comes to the left side, it will only be less than the mean. It will not be negative. It will extend up to that side. Okay, so now let us start doing this. Now I want to know the value of x less than 450. So it is going to be this region which I will like to shade. I want to know that value. So for that I need to first know what is this one. This is 0.5, and then I need to know what is this one. Okay, so I need to know what is the z value of 0 to minus 1.04. Come with me to the table. 1.04 is the value. Okay, so 1, the first is 1.0. So under that 0.04 column, it is going to be 1.04, 0.3508. So 0.3508 is the value which I need. So the value is 0.3508. Okay, so this value is 0.3508. So if I want to find the value here shaded, then the required area or probability is equal to 0.5 minus 0.3508. This is going to be equal to 0.1492. So the number of workers with wages less than 450 is equal to 0.1492 into 500, which is 74.6. We can round it off to 75 workers. Copy this down. The next is between 548 and 600. This means P of 548 less than x less than 600. Okay, so for this let me again find the z value. First of all, z value is equal to x is 500 x is, sorry, okay, now I will have two z values here. Okay, first of all, okay, I will do one thing, I will do it separately. There are two z values for this. The first one uses x as 548. Okay, so when I say x is 548, when x is 548, z is equal to 548 minus 500 by 48, which is 48 by 48, which is 1. And when x is 600, z, we have already done this, z will be equal to 2.08. Okay, 2.08. Now let me draw the diagram. Z is 0 and mean is 500, and 548 comes here. This is x equal to 548 and this is x equal to 600. When x equal to, okay, I will draw it a little bigger for you so that you get more clarity. It will be a little confusing this way. Okay, look at this diagram now. Okay, so this is z equal to 0 and this is mu, which is 500. Then this is x equal to 548 and this is x equal to 600. At this value z is 2.08 and at this value z is 1. Now I need to find out the value of probability of 548. X should be less than 600, but it should be more than 548, which means this is the area which I require. X is more than 600. X is more than 600 when x should be more than, sorry, x should be less than 600. X should be less than 600 means it is this value, and x is more than 548 means it should be this value. Let me again explain. The third subdivision, P of 548 is less than x less than 600. That means x is less than 600 but x is more than 548. Here we will have two z values. When x is equal to 548, z will be equal to 548 minus 500 whole divided by 48, which is 48 by 48, which is equal to 1. And when x is equal to 600, we have already calculated z. Z is equal to 2.08. So with these two values we have to find out. Now let me take the diagram. Okay, I will take the diagram here. I've drawn it a little big to make you understand. It is a little complicated and it has two values, x values. Here this is the mean. Mean is 500, and when the mean is 500, z is equal to 0. Now here I will draw 548. X is 548. I'll draw here. At that point z is equal to 1 and x is equal to 600. There are two values here. I will draw both. I am plotting both. X is equal to 600. At that point z is equal to 2.08. Now look at this carefully and tell me where is the required region which I have to shade. Now the shaded region is, one portion is x should be greater than 548 and x should be less than 600. X should be greater than 548. It should be greater than 548. So for x to be greater than 548, the required region would be this. This is the required region for x to be greater than 548. And for x to be less than 600, at the same time x has to be less than 600 means that region would be, the required region for me would be, I will denote this, the first one I have denoted in green, and the one now x less than 600 means it would be here. This is x less than 600. Between these two regions The only thing which is overlapping, it should overlap, both conditions should be met. So the overlapping region for that is this region. It's more than 548 but it is less than 600. It is this region. So this is the region which is matching both the conditions. So I need to find out the area of this portion. But how do I find out the area? Look at this carefully. I know the area. I can find the area of this portion. I can find the area of this portion. Let me call it area 1. Okay, for your understanding, I am denoting it as area 1. And I can find out the value of this area. I'll call it area 2. Okay, so I'm trying to find out the value of 0 to 1 and the value of 0 to 2.08. If I find out these two, then the difference between those two will give me the resulting area which I require. Okay, I'm going to repeat once more. I have shaded this region in red, in which one the region which we need to calculate the area for. That region I need to calculate using the below understanding. The action which I need to perform now is I have to first find the area between 0 to 1 and then the area between 0 to 2.08. That will give me the difference between the two, will give me the required area. Okay, so this would be the area required, or the probability required. It will be equal to 1 to 2.08. Let me go to the table now and I will tell you 1 to 2.08. Here 2 is here, 2.08 is here, 0.4812. So I need to first take 0.4812. From that I need to subtract 0 to 2.08 is 0.4812. 0 to 1 I have to find out. So I have to find out 1.0. 1.0 is 0.3413. 0.3413. The difference between the two will give me 0.1399. Now the number of workers required is equal to 0.1399 into 500. This gives me 69.95, which is 70 workers. This is my answer, 70 workers. So the last question was a little bit tricky, but it is quite simple if you understand it this way. First you find out the area between 0 and z is 0 and z is 2.08, and then deduct the area between z is 0 and z is 1, and you will get the required probability. Multiply that by the number of workers, mean workers. That's it.